Today's day 3, lesson 3 of learning about Despina and her submersibles and being an underwater engineer. So someone help us out with the guiding question for today. Read that out loud.
How does the mass and volume of an object affect whether it sinks or floats in water?
Okay, so you see these two words that are underlined, super important. Mass is what something is composed of, right? Composed of. Volume. Who can define volume? Easy one. You should know it by now. Go ahead.
How much space an object takes.
Exactly. So let's take a look at our bar of gold and our eraser that we've been referring to. Which one has more volume? Is there one with more volume? Are they the same? Which one's greater, equal? What do you think?
They both are the same.
Thank you. We're good. Okay. Which one has more mass? The silver or the eraser?
The silver.
Silver has more mass. So the silver has more weight, and the silver might be more dense. That's another big word for today. Okay. We're going to talk and we're going to control and conduct an experiment that relates to collecting data about the properties and behavior of vials that are filled with different materials. You have 6 vials in front of you. They're filled with sand, pony beads, which are plastic, and glass marbles. We're going to see how they relate to the buoyancy, the density, the volume, and mass as far as, how they float, sink, and so forth. So what you have in front of you are these 6 vials, which represent 6 different components to the submersible. At this point, I'd like you to take out your worksheet, and you're going to see in front of you on page 1 of your worksheet this big basin of water. They're calling it a basin. We have tanks that are rectangular for you. So what I'd like everyone to do, one person each will take a vial and put it into the water, okay? And then you're going to record on the picture what that vial looks like. So for example, they already did the battery for you. I'm going to take my battery, drop it into the tank, and we'll see that the battery rests on the bottom. So I just want one person to put in one vial. We'll take our turns and go around, and everyone's going to record their data. We'll reconvene back here at the board in 5 minutes, and we'll see if everybody has the same data or if we have some outliers.
Just drop the whole vial in. There you go, now record it.
Wait a minute, Jeremiah. Is it going to sink or float? What do you think?
No, sink. No.
Okay, good. You guys are making predictions before you put it in there?
And this already sinks. I think it's gonna.
Wait, what is that?
What is it?
No.
Sound
Camera.
Wait, a video camera?
Yeah.
I think it's gonna sink. It's gonna float.
Loaded.
Gabby, when you draw it, make sure you draw it exactly the way you see it in the tank. It might be sitting on its side. It might be sitting straight up. You guys are moving fast? That's good. All right, so from this group, who wants to volunteer to come to the board to tell me where your vial went? Andy and Hanley, come on up, okay? Bring your data sheets with you so you know exactly what happened. I'm going to ask you guys to do the vials that are on the top. So put here where you recorded your video camera and your temperature sensor in the basin. Okay. The temperature sensor and video camera are both buoyant and they float. They're less dense than water, okay? So everyone agrees with these pictures. Okay, let's do a quick exercise. Let's focus on the battery and the manipulator arm. Now, we have 3 variables we have to look at when it relates to the buoyancy of an object. And the 3 variables we're going to focus on in this lab today are volume, mass, and density. You think the volume for these 2 are equal to each other, or one is greater than the other? What do you think about the volume? Go ahead.
The same.
The volume's the same. Excellent. You're the first class that's been able to answer that right on the first go. The volume for both are equal because the vials are equal. They're the same size vial. Now, let's talk about the mass. Which one has a greater mass, you think? The battery, which was down low here, or the manipulator arm, which floated? Hanley.
The battery.
The battery has more mass because there's more stuff in it. That gives us a clue as to density. Density and mass are closely related. Which vial has more stuff in it, thus has more density to it?
The battery.
The battery is more dense, okay? And we can confirm that by seeing where it ended up. If it was less dense or less dense than water, it would float. So I'm going to use an arrow down. This one that's half full is less dense than the one that's full of sand. Okay? We good? So we all in agreement with mass, volume, density. We know what they mean by now? Now, what you have in front of you is a pan balance. What I'd like you to do is to get your vials in order from most dense to least dense by weighing these two vials compared to each other, okay?
This one. Oh. Yeah. So that one, and then now the sand. The battery. Yeah, the battery.
So your video camera, you have a lot of pony beads in this one. It makes sense that this would be heavier, okay? So let's compare that. Let's compare the heavy pony beads to manipulate around. Ooh. Good. So you can draw conclusions. This is just a simple balance. Good.
So this one's more dense. The video camera is more dense than the...
Can I see the pictures? Yeah.
Okay, what I'd like someone from this group to do is come up and take those vials and put them in order from most massive to least massive. She's putting her groups in order. I want to see if you guys agree or disagree and why. And then we'll contrast it with Group A and we'll see if everybody's on the same page. So Group B, do you agree with this setup? Battery, light, manipulator arm, sound recorder, video recorder, and temperature sensor? You're in agreement with that? So Group B checks, okay? In Group A, how do you feel about this order of density? Do you agree or disagree? You have the same? You do. So everyone's in agreement. So when we all come into agreement again like this, we can draw conclusions because everyone's on the same page. 20 people share the same opinion. We're going to say that it's true. So that information is going to be really important when we put together our submersible, because in the end, if that submersible should lose power or if the tether breaks, what do we want that submersible to be able to do? Very good. We want that submersible to be able to be buoyant and to be able to float so we can retrieve it, because that submersible is expensive and it's loaded with the data that we collected. So in the end, your submersible needs to be buoyant. It needs to be able to float. It needs to be less dense than water. How do you guys feel about today? Thumbs up? Yeah, I think a big part of the success with the EiE and what makes it practical is that the materials are easily accessible. They're inexpensive. In no way is cost ever a factor when we're taking these lessons on. That's the last thing we think about is, can we get the materials to pull this off? It doesn't require an interface or some type of lab. They've really done a good job at assembling the kits so that it's not a cost burden.